Everyone, today I'm going to show you how to do the conjugate heat transfer using ANSYS Fluent. First, I have drag and dropped a fluid flow simulation block to the workbench. Then I have opened the design modeler, and what I'm going to do is I'm going to create a small box inside the bigger box. The bigger box will be the air domain, and the small box will be the metal cubic or aluminum cubic, which generates heat, and we will see the heat transfer between the cube and the air. So first on the ZX plane, I will create a sketch. In the sketching mode, let's draw a rectangular or cube to make a cube. So let's do the dimensions. 10 by 10. 10. So let's just set the distance here to here, 20, 15. So let's go to the modeling, extrude, select this sketch, and 10. If we go to the perspective mode, we will see that the cube. Click generate. So we have the small cube now. Let's create another rectangle shape and the cube on the XY plane and extrude in Z direction. So click on XY plane, new sketch, go to sketching mode, rectangle, and this time let's create a 40 by 40 rectangle or a square. Now go to the modeling, sketch 2, extrude. This time I will go to, let's say, 100. So as you see, we are going to create this cube. So instead of add material, I'll do the add frozen, so it will not merge them together, so it will create two separate boxes. So I have created this box. Now I need to subtract the small box from the bigger box. Select and create Boolean, subtract, like here in drop down menu, subtract, or you can double click on that, it will change. Target body, the bigger box, tool body, smaller box. Here we want to keep this smaller box. So generate. So as you will see, if we select the smaller box and hide it by pressing F9, so there's a like cavity in the box shape in this bigger box. So now I will close the design modeler, and I will open the meshing. So for this in this video I will show you one way of creating the mesh interfaces, because in Fluent, when we want, or in most of or all of almost CFD softwares like CFX and Fluent, we need to define mesh interfaces for the conjugate heat transfer when two materials are in like fluid and solid are in touch with together. We need to define the mesh interfaces. In this video I will show you one method, and in another video I will show you how to define the interfaces. Two other methods we have. We can create automatically, like in this video, in the meshing software, and also we can define name selections manually in the meshing software, and then create the interfaces, mesh interface inside the Fluent, or we can create our geometry in a way that we don't need to do anything in meshing, but Fluent will automatically create the interfaces for us. So the first method, now if you open the meshing with a simple geometry, it automatically creates this interface. So first let's the outer cube, let's rename it as air cube, and like the inner, let's keep the solid. So if you click on the contact region and go to the details, you will see that 5 phase selected from contact, which is solid, which is this small cube, and 5 phase selected like the walls of that hollow selected from the air cube. So ANSYS meshing automatically identifies this contacts. For the simple geometry, it's easy to check, and most of the time ANSYS meshing will do the job for you, but for the complicated geometries, most of the time it will not work properly, and or you can't check if it's identified properly, because you will have the geometry will be too complicated to check the contacts one by one. So if I delete this contact, simply I can right click on connections and click on create automatic contacts, and as you can see, it will create the same contact again. So let's leave this one as is. So to create the mesh, first let's try and just generate the mesh to see how's the meshing. So as you can see, let's go to section plane here, create a section plane to see what's going on inside the mesh. This is a very coarse mesh, so you can see that there's a tet mesh for the air and hex mesh for the cube. So for this case, to have a less number of nodes and have a hex mesh for everyone, I want to do the cut cell assembly mesh. For the sizing, I would like to, let's try 4, which creates 2.8 automatically. The ANSYS kind of chooses the in-between numbers based on the cut cell method. Generate the mesh, see how it looks like. Okay, this is reasonably nice mesh, so we can change the size or keep it as is. So let's put 3, 2. So it's finer mesh, and as you can see the number of the nodes and elements here. So I will define name selections for boundary condition. Let's define this part, name selection, or simply click N as outlet, this back face as inlet. It's better to put the inlet keyword in the inlets and outlets to in this case Fluent automatically will identify them as inlets and outlets when you load the mesh to the Fluent. So let's hide this, let's name this volume as air, or let's put fluid, and I will hide this. To hide, you can simply click F9 to hide the body and F8 to hide the face. So let's name this one as the cube. Like heat cube. Okay. So show all bodies, update mesh. So we sent the mesh to Fluent. Let's close the meshing and open the Fluent. So I have make sure you check the double precision. I have 8 CPUs on my machine or on my laptop, so I'm using the Intel MPI. If you don't know, as I mentioned in previous videos, just leave as it default, but if you know, if you choose the proper MPI, it will slightly faster than the default. So let's start the Fluent now. First thing first, always check your mesh to avoid any bad quality mesh. We'll go with the pressure-based steady state simulations. So let's turn on the energy and just standard K epsilon for the viscous flow. Go to the cell zones. This is it's identified as this fluid as the fluid, and double click on the fluid. Make sure this is air. So if you have many different materials, it's important to check which material it's assigned. So now, since we have only air in the fluids and aluminum in the solid, so it will automatically every fluid as air defined as air, and every solid as aluminum. So we want to have a heat generation on this cube, so create one source term as constant. Let's put 100 watts per meter cube. Click OK. Go to boundary condition, group them by zone type. As you can see, it's the inlet is defined as the velocity inlet because of the name of it. We assign to inlet. So let's have a flow with 0.01 meter per second, and change the temperature unit. Okay, with 20 Celsius temperature. Click OK. You see here we have a wall fluid heat heat cube, a wall between fluid and heat cube, and another one between fluid and heat cube as shadow. This is the interface that Fluent identifies it and creates a mesh interface, kinda mesh interface with a coupled, thermally coupled. So it's kinda creates a virtual layer which is thermally coupled with this that cube wall. So if we display, not here, sorry, right click here and display this one, you can see this is the cube, and if we display the shadow, nothing changes, it's the same cube because it's a kind of virtual wall as a shadow at the same location to just do the calculations. So now we will initialize our case or simulation. Now let's do 300 iterations, and I will run the calculations. It will take a while. I will fast forward the calculation stage to save your time, and I'll get back to you when it's done. Now the calculation is done. Let's click OK. We can create counters here, or let's go to close Fluent. And open the CFD post or results. So in the CFD post, first let's create a plane on YZ plane, and the distance will be 20, so it will create a plane exactly in the middle. So let's turn this plane off and create a counter of temperature, and the domain, let's play only fluid, the location on the plane 1, and let's do the local range first. So since the temperature close to close to heated cube is very high because of the high heat generation we defined, we can't see how the counters, the air is heated. One way is to increase the number of the counters so it shows more, but it's better to define the temperature range, which is let's do 400 Kelvin. Let's reduce this number. So as you can see, it shows better because we kind of eliminate very high temperatures very close to the cube, so it shows how the air is being heated by this cube, which has a heat generation. The other method of showing the temperature is creating a volume rendering temperature. Let's do the user specified like 293 to it was 400. Okay. On the fluid can see this shows a very nice volumetric rendering of the temperature and how heat flows over the cube, and the temperature is changing. So we can increase this resolution to have a better density. It'll take a while, so you can see this temperature volume rendering. So thank you for watching this video. If you like our videos, please subscribe to our channel, like our videos, and share the videos with the people you think that it will be useful for them. Also, please to refer to the link below. In that link I will explain how to select and create interfaces for the CFD simulations with the Fluent. Thank you very much.